Okay, all right, enough about checking things on the calculator. Okay, so again, check your maximums and minimums of your function and see if they line up with the x-intercepts of your derivative. So that's one way you can check it. All right, level 2. So level 2 is, can you use the fancy rules, the chain rule, the product rule, and the quotient rule when asked to? So number 2a, f of x is equal to 2 times 3x to the 4th minus x to the 3rd. Find f prime of x by the chain rule. So we're going to use the chain rule. You're being told you're using the chain rule. I like to do u substitution when I have the chain rule. So u is what's in the parentheses in this case. And usually it is, but not always. So now I'm going to rewrite this with 2, and then this is my u, and it's to the 3rd power. Now I'm going to take the derivative of each of those. So 4 times 3 is 12, minus 1 for my exponent. The negative x, my invisible exponent is 1, bring that down in front. And then my derivative of this one, 3 times 2 is 6. Minus 1 for my exponent, and now I'm just going to multiply these together. So f prime of x is equal to 12x to the 3rd minus 1 times 6u squared. But now I need to substitute back in what was my u. So I'm going to have f prime of x is equal to 12x to the 3rd minus 1 times 6 times 3x to the 4th minus x. Okay, and that would be squared. Oops, forgot the squared. Because my u is being squared. Okay, and I'm not going to make you expand it. Okay, you don't have to simplify it. You can just leave it right like that. Because this is level 2. I just want to know, can you use the basic chain rule? All right, so you don't have to go any further than that. Just can you set up your u substitution and use the basic chain rule? So that's a fine answer. Go ahead and leave it like that. We're not math-based today. All right, next one, product rule. So letter B, I have y equals 5 minus 3x times x to the 4th minus 2x, and I want to find the derivative. By the way, I'm just checking my answer here, make sure I didn't make any mistakes. Yep, that's fine. All right, back to this one. So this one, product rule. Again, I can use my formula packet. Okay, got my formula packet handy. Here's my product rule. I have to recognize that I have two functions being multiplied together. So I'm going to separate those out. U is equal to 5 minus 3x is being multiplied by x to the 4th minus 2x. Then I take the derivative of each one. So this one just becomes negative 3. And this one becomes 4x to the 3rd minus 2, using our basic derivative rule. Then I am going to crisscross applesauce. Okay, if I remind myself, it's u times the derivative of v plus v times the derivative of u. So my dy dx is going to be equal to 5 minus 3x times the derivative of v plus, going the other way, x to the 4th minus 2x, v times the derivative of u. Okay, and that's it. You do not have to multiply it out. You can just stop right there. Okay, let's see. When I did this before, did I bother to multiply it out, or did I just leave it like that? Oh, I actually went ahead and multiplied it out. If you do multiply this one out, which I think I did I do that one? No, I'm looking for my work. Huh. Let's see my... So I multiplied it out. So if you do multiply it out, you want to see what you got multiplied out. It ended up being, I got, where is it? I got negative 24x to the 4th plus 20x to the 3rd plus 12x minus 10. Okay, but I'm okay with this. For a level 2 question, I'm just looking to see, can you apply the basic rule? So if you can just get to this, I'm fine with that for the level 2. Okay, just using the basic formula. You don't have to actually simplify it. All right, and then letter C. we have our quotient rule. So if y is equal to 7x squared minus 3x over 4x squared minus 5x plus 2. So again, you're looking at referring to my formula. It's v times the derivative of u minus, oops, can't see that, minus u times the derivative of v, all divided by v squared. Okay, so I need to set up my u. I need to set up my v. I need to find each derivative. And then I need to do my crisscross applesauce. Now be careful on this one. It's the v that goes first. So it's this one that goes first. So my dy dx, it's going to be this one first. 4x squared minus 5x plus 2 times the derivative of u minus, then this one, 7x squared minus 3, oops, can't see what I'm doing, sorry, minus 3x times 8x minus 5, all divided by v squared, 4x squared minus 5x plus 2 squared. And that's it. You can stop right there. You do not have to simplify it. You can stop right there. Okay, if you did go ahead and simplify it, I apparently did not. I'm looking for my answer somewhere on my papers, and it looks like I didn't bother to finish that off. I stopped right there. Okay, and that's fine. For the quiz, you can just stop right there. This is level 2 after all, just using the basic thing. Okay, level 3. Where's my question? I misplaced it. Okay, level 3. Now you have to decide, what should I be using on this one? So level 3, letter A, I'm given f of x is equal to natural log of x minus 5x squared. Well, look at that. I just have two functions being added together. So I don't need to use any special derivative. This is actually kind of a basic one. I don't need the chain rule. I don't need u substitution. I don't need the product rule or the quotient rule. These are just being basically added together. Okay, I can change this to plus and negative. So all I got to do here is just go ahead and take the derivative. So the first one, natural log of x, is going to be 1 over x. And then for the next one, 2 times negative 5 is negative 10. Subtract 1 from that. There you have it. Okay, the one thing that I do need to be careful of is I do have a natural log, so therefore I do need to limit the domain. So what is x? It has to be greater than 0. Okay, that's it. I just need to be careful on my natural log. All right, the next one, B, I have f of x is equal to natural log of x minus 5x squared. Now we're talking chain rule. I have a function inside of a function. I have something inside my parentheses that I could change to u. So I'm going to say u is x minus 5x squared. So therefore, y is equal to natural log of u. Now I'm going to take the derivative of each one. So I get x becomes 1, 2 times 5 is 10, minus 1. And the derivative of this one is 1 over u. Then I'm going to multiply those together. So f prime of x is equal to, I'm going to put this one first because it just seems easier for me that way, 1 over u times 1 minus 10 over x. Now I need to substitute back in for my u. So f prime of x is equal to 1 over x minus 5x squared times 1 minus 10x. And then I can put that in my numerator. So I get 1 minus 10x over x minus 5x squared. Okay, I do need to watch out for my domain restriction. This guy right here, x minus 5x squared, has to be greater than 0. So I need to solve this. It's a quadratic, so I can factor out an x. If I factor out an x, I get 1 minus 5x, and that is got to be greater than 0. So that means x has to be greater than 0. Well, actually, I'm going to change it to equals for a moment. 1 minus 5x equal to 0. I'm going to solve these for being equal to 0. So this one, I'm going to add my 5x to the other side, so 1 equals 5x. Divide both sides by 5, I get x is equal to 1/5. Now, why did I change that to equals to 0? Because last year we learned when you're solving a quadratic inequality, you actually have to graph it. So I'm going to graph my x-intercepts, which would be 0 and 1/5. Well, we'll just call that 1/5. Don't worry about scale too much. This parabola, is it happy or sad? Notice it's sad because the x squared is negative, so it's like that. And I want to know, where is the derivative, where is the y value, where is x minus 5x squared above 0? So that would be here. So my limiting value for this one is actually that x has to be greater than 0, but less than 1/5. Ooh, that's tough. That one's a tough one. Okay, so you know what? I'll try not to give you one that hard. Although this is level 3. I probably won't give you a quadratic one. I'll be nice. I will not make it a quadratic domain restriction on the quiz. Okay, but if we were really finding it, this would be it. And if you check it in Desmos, you would see that that actually does work. Of course, you can't use Desmos on the quiz, but this is the domain restriction. So our final answer here is the derivative is equal to 1 minus 10x over x minus 5x squared with the domain restriction of x is greater than 0 but less than 1/5. Crazy. Okay, I'll give you an easier one so that you don't have a quadratic that you need to find the restriction on. I'll be nice. Okay, letter C. Oh, I gave you 2 B's. Sorry. This is meant to be a letter C. Letter C. I'm doing on time. Oh my gosh, the bell's about to ring. We have f of x is equal to negative 5x natural log of x squared. Okay, so notice I have negative 5x times natural log of x squared. This is a product rule. This, I'm going to be using the product rule. So u is equal to negative 5x, and v is equal to natural log of x squared. But then here I have a chain rule. Oh my gosh. So I've got like a bunch of rules put together. So anyway, let's do u prime is going to be negative 5. V prime is going to be, I'm going to have to use the chain rule on this. The derivative of natural log of x squared is 1 over x squared, but then I need to multiply it by this derivative, which is 2x. So that gives me 2x over x squared, which reduces down to just 2 over x. Wow. All right, so then my total derivative is equal to, multiply those together, negative 5 times, oh wait, sorry, we're doing the product rule, so I got to do this. Bam, sorry. Forgot. Okay, so what am I doing? I'm doing u times v prime, which is 2 over x, plus, crisscross applesauce, negative 5 times natural log of x squared. Okay, and then I can simplify this a little bit. This would give me, the x's are going to cancel out, negative 10. And I can change this to just a minus, ooh, just ripped my paper, minus 5 natural log of x squared. Okay, so that is the third one, which was second letter B, which I just changed to a letter C. Okay, next problem. Oh, running out of paper. Letter D. So level 3, letter D. F of x is equal to the cubed root of x to the 4th minus 1/2. Okay, so in this situation, I've got this radical. So I don't like that. I'm going to rewrite it with a fractional exponent. So this is x to the 4th raised to the 1/3. Power on a power, I can multiply those together. So this becomes x to the 4/3 minus 1/2. Now I can take the derivative of that, and I get 4/3 x to the, I need the minus 1. 4/3 minus 1 is the same as 4/3 minus 3/3, which is equal to 1/3. And the derivative of negative 1/2 is just 0. So here is my derivative. And that's it. That is the answer to D. Okay, now for the big one. Problem, where am I? This one, I'm going to do it right on here. Okay, so I've got a function, f of x, which notice is not graphed on here. And I have g of x, which is graphed on here. It's 1 over x. And it shows the derivative of this guy right here. And it tells me that the derivative has an x-intercept. Here's my x-intercept at x equals p. So this value is p right here. Now, I want to remind you about something I mentioned before when I was talking about using your graphing calculator to check your derivative with your function, that when the derivative equals 0, you should have a maximum or a minimum on your original function. So I know this point right here coincides to a max or a min on f of x. Keep that in mind. That's a super important concept. Okay, show that the derivative of f of x equals this. So we actually have to calculate the derivative. So I'm going to do it over here on the side. So I know that f of x is equal to natural log of x squared over 2. So I see a function inside of a function. So I'm going to do u substitution. U is equal to natural log of x. So y is equal to, sorry, no, that's right. So u is equal to, y is equal to u squared over 2. Sorry, I'm starting to panic because 5th period is almost over. And then I'm going to take the derivative of both of those. So I'm using the chain rule. I'm seeing that this looks like the chain rule to me. So the derivative of u is 1 over x. The derivative of y is equal to, well, I'm going to rewrite this actually before I take the derivative. I kind of don't like having that 2 on the bottom. I'm going to rewrite it as 1/2 u squared. I like it better like that. Now I'm going to take the derivative. 2 times 1/2 is just 1. That's why I did that. 2 times 1/2 is 1. So it's 1. And then u to the 2 minus 1 is just 1. Now I'm going to multiply those together. So my derivative, f prime of x, is equal to 1 over x times 1u. So f prime of x is equal to 1 over x times, what was u? U was natural log of x, which just gives me natural log of x over x, which is what I was trying to show. Okay, so you should end up with this answer. Nice little show that problem. Now, there is a minimum on the graph of f. Oh, wasn't I just talking about this? Find the x-coordinate of this minimum. So there's a minimum on the graph of f. Find the x-coordinate of this minimum. So remember, the x-intercept of the derivative corresponds to the minimum of the graph of f. I don't know exactly what f looks like, but we know it's going to have a minimum. So let's say it goes like that. I know it's not a parabola, but what the heck, let's just pretend it is. Remember how in the Desmos card sort, that's how we checked, that's how we paired up derivatives with our functions, is we lined up the minimum or the maximum of the function with the x-intercept of the slope function or the derivative. Okay, the slope at a minimum or maximum is 0. Here, the value of the derivative is 0. What does y equal here? It equals 0. That means the slope is 0 on the function at that point. So these x values are going to be the same. All right, so how do I get the x value here? Well, we get the x value here when y is 0. So to get the x-coordinate here of this minimum, I'm going to have to change y to 0. So it's going to be 0 equals natural log of x over x. Multiply both sides by x. I get 0 equals natural log of x. Change that to exponential form. The invisible base is e. So e to the 0 equals x. What is e to the 0? 1. So my answer is the x-coordinate right here, right there, is 1. So what's the value of p? Oh, 1. P equals 1 because that's the same thing as the x, because they told us x is the same as p. Now, the graph of g intersects the graph of f prime when x equals q. Find the value of q. So I want them to intersect. Where are these two intersecting? we set them equal to each other. So g of x is 1 over x, and f prime of x is natural log of x over x. Notice the denominators are the same, so that means we just set the numerators equal to each other, because they need to be the same. Now I'm going to change this to exponential form again, natural log, base is e, so I'm going to write e to the power of 1 is equal to x. What's e to the power of 1? Just e. Oh my god, that's it. Okay, so the value of q is equal to e. Okay, and the critical thing, all you needed to know is that the x-intercept of the derivative is the same as the x-coordinate of the minimum or the maximum of the original function. That's the key thinking on this problem. All right, bye.